Hello everyone. Okay, so today we're going to be doing the Physics Paper 1, 2019, and we are starting with question 2. The scenario in this question is that there are two blocks that are connected by a string and they are on a slope which is 30 degrees. The block at the top of the slope, which is block Q, is 3 kilograms and it's being pulled with a force of 40 newtons at 25 degrees to the surface that we're pulling it to. And block P is attached to block Q. Block P is 2 kilograms, and block P is currently on a rough section of the slope and it's rough between A and B. Okay, so that is what is happening in this question. And it tells us that there's an average constant frictional force of 2.5 newtons on block PE as it moves from A to B up the incline. So our first question is to state Newton's second law in words. So the answer to that question is when a net force acts on an object, the object will accelerate in the direction of the force with an acceleration that is directly proportional to the force and inversely proportional to the mass of the object. So this question is worth 2 marks, and the places where you will get your marks is you will get a mark for to say net force, or you can also say resultant. Also say resultant force, and then you'll get another mark for saying with an acceleration that is directly proportional to the force and inversely proportional to the mass of the object. So you'll get 2 marks there. The next question is they're asking us to draw a labeled free body diagram for block P. First of all, before we do that, let's analyze and look at block P and all the forces that are acting on it at the moment. Okay, so the first force that we have is for every single thing, gravity acts on it. Gravity acts straight down. So on block P, we've got force of gravity acting straight down. And the force that counteracts the force of gravity is the normal force, which acts at 90 degrees to the surface. So it's going to be acting at 90 degrees to this surface here. So normal force, normal. Then we have the force of the string pulling this block P up the slope. So the force of tension. So it is, we can just write, I'm just going to write tension, T, tension. And then we have been told that this is a surface that has friction. We've been told this, an average constant frictional force. So there is a frictional force. So we're going to put that frictional force in. The friction always acts directly opposite to the tension force or to the force that is pulling the object up the slope. So therefore the friction is going to be acting down the slope, and we're just going to put small f for friction. Okay. Now we can go nicely and draw a free body diagram for block P. So I'm going to do that over here. This is question 2.2. Our free body diagram for block P. All we need to do is we're going to start with a dot that represents our block. We can start with the force of gravity, Fg. Counteracting that force is the normal force, which is at 90 degrees. So 90 degrees to this imaginary slope that's over here like that, which we're not going to put in because this is a free body diagram. So that is the force, the normal force normal. Then we have the tension pulling us up the slope and the friction pulling us down the slope. Please remember to keep your lines nice and straight. Use a ruler, and we should actually be having these all trying to be the same length. Okay. For this question, this question is with 4 marks, 4 nice, easy marks. You can see here, this looks pretty much the same as that, except we've got a dot. Okay. So this is with 4 marks. So we get 1 mark for the force of gravity going down, 1 mark for the normal force at 90 upwards 90 degrees to the surface. 1 mark for the tension and 1 mark for the friction. Okay, 4 nice marks. Now we come to the actual bulk of the question in question 3, 2.3, which says, calculate the magnitude of the acceleration of block P while block P is moving on section AB. Okay, so when we're thinking about this question, we think about what possible formulae could we use for this question. So our most basic formula is that F net equals mass times acceleration. Okay. Now, we know that the net force on our block is going to be something like the tension pulling it up, and then we're going to have to minus the friction, and then gravity is also going to play a role in this because it's also going to pull it down a bit. So yeah, so we've kind of got what our net force is going to be. We just have to work it out. And we know what the mass is. The mass is 2 kilograms, because we've been given it here, but we don't know what the acceleration is. Okay, and we also don't know what the tension is. We know what the friction is. We've been given the friction, which is 2.5 newtons. We don't know what the tension is. We don't know how much force they're pulling the block up with. So from the looks of this, we're going to have to make a free body diagram. Not a free. We're going to have to do simultaneous equations with block Q to try and work out what this acceleration of block P is. Basically, what we're wanting in the end here is to get what is this A? That is what we're trying to work out. Okay, so we said that the net force is going to be the tension going up, which we don't know what that is. We are going to be using the frictional force, which we know is 2.5 newtons. And we said that the force of gravity is also going to have some effect. The gravity is also going to pull us down the slope a bit. So we need to work out by how much force is gravity pulling us down the slope by. Okay. And we are going to do that by using our trigonometry. And I'll explain how we're going to do that right now. So the force of gravity has 2 components. We have the component that is counteracting this normal force, so it's acting at 90 degrees to the slope. And that is the force of gravity perpendicular. And then we have the other component of our force of gravity is the force of gravity parallel, the part that is pulling us down the slope. Because if you have a ball and nothing else is acting on the ball except for gravity, and the ball is sitting on a slope, and the ball is always going to roll down, and that is because of the force of gravity that is acting parallel to the slope. Okay. We know that our slope is 30 degrees. And because of our wonderful geometry, we know that this is 90 degrees, that is 90 degrees, and therefore this angle is also 30 degrees. So this angle and this angle will always be equal. You should be given this angle. You might have to work it out maybe in a question. It's always equal to this angle. So we know that gravity is equal to mass times acceleration, which is 9.8 meters per second, because that is the acceleration that gravity is pulling you down at. Okay, so our FG here is 2 times 9.8. Okay, we want to work out what the FG parallel is. FG perpendicular doesn't have anything to do with what the net force is, because we're just wanting the net force in this direction. The net force isn't acting in this direction, the net force is acting in that direction. So we only want the force of gravity parallel. So to do this, we are going to remember that sine of an angle is opposite over the adjacent. So sine of 30 is FG parallel over the FG. Okay, therefore, the FG parallel, which is the one that we want, is equal to FG, normal force of gravity, times the sine of 30 degrees. Okay, so now we know what this is. We know what the friction is, but we don't know what the tension is. So we are going to start now with our working out. So 2.3. We are going to start working with block P. So we're going to write here nicely for the examiner so that they know what we're talking about. For block P, F net, the net force acting on the object, is equal to mass times acceleration. Okay, you will find this formula on your formula sheet. You need to know it. Okay, we said that the F net would be equal to the tension, which is going up the slope, plus the force of gravity that is parallel, which is working down the slope, plus the force of friction, which is also working down the slope, and that is equal to m times a. Okay. So, because these are both working down the slope, we're going to say that they are negative. We're going to put negative in there, and then we are going to simplify our equation, and we're going to say T minus FG parallel plus F equals MA. Basically, all we did was we took out the negatives, put them in front, and then we plus them together. Okay. So we don't know what the tension is. We're just going to write T. I told you earlier that FG parallel is equal to FG sine 30. Also told you that FG was equal to 2 times 9.8. So FG parallel therefore equals 2 times 9.8 sine 30. And we were told that the frictional force is 2.5 newtons. And we know that the frictional force is acting, and then, yeah, so is 2.5 newtons. Okay, now we're going to simplify this. We're going to put our minuses back in. Get T minus, and then we minus 2 times 9.8 sine 30 minus 2.5 equals MA. If we work this out on our calculator, we get T minus 9.8 minus 2.5. And if we sub in the mass of the block, which is 2 kilograms, equals 2A. Okay, now if we simplify this a bit more, then we get, therefore, T tension minus 12.3 equals 2 times the acceleration. This is our first equation using block P only. Now we are going to move on and use block Q to hopefully work out what the tension is, because tension is also acting on block Q. Okay. Now we're going to start for block Q. We are going to use the same equation at the beginning, which was F net equals MA. Okay. Now, what forces are acting on this block Q? We have again our force of gravity, and therefore our force of gravity that's perpendicular, and our force of gravity that is parallel to the slope. We have the tension in the string this time is pulling block Q downwards. This tension is pulling block Q downwards because block Q is pulling block P. And then we obviously also have this force pulling the block upwards, and we have the normal force as well. So our net force is going to be the ones going upwards minus the ones going downwards. So the force minus the tension plus the FG parallel. Okay. Now, for this force here, this force is not 30 newtons because we need to get what forces are acting in parallel to the slope. So we're going to have to use the 25 degrees to figure out what this force is. We want this force acting parallel to the slope. So we are going to work that out using our trig. Okay, so that is 25 degrees. We have the make a triangle here. This is the hypotenuse, and this is the adjacent angle. Okay, so what is one that we can use the hypotenuse and the adjacent angle? It is cos. Okay, so we're going to use cos. So the cos of 25 degrees is equal to the adjacent angle, which is our force that we want, over the hypotenuse, which is the 40 newtons. Therefore, the force that we want is 40 newtons times the cos of 25. Okay. Anything else we need to work on? Yes. The force of gravity perpendicular again. This force of gravity perpendicular is different to the force of gravity perpendicular we just worked out earlier because these blocks are different weights. But we're going to use exactly the same method. So basically, this angle over here is also equal to 30 degrees, same as that angle and that angle. This is also 30 degrees. Okay, so we're going to do exactly the same thing. We are going to say sine 30. Let me write it down here in a different color. Sine 30 is equal to FG parallel over FG. Therefore, and our FG here is now 3 times 9.8 because it's 3 kilograms, this block. So now our new FG parallel for block is 3 times 9.8 sine 30. Okay, now we can go and work this out nicely like we did before. Okay, so now for block Q, the F net is T, oh sorry, not T, is if the force that the block is being pulled up by, that we just worked out, this one over here, and plusing the parallel force of gravity that's working down the slope, force of gravity parallel plus the tension, plus the tension. And because these are working in opposite directions of each other, we're going to say minus. Okay, that is equal to MA. Because the tension is working down the slope for this one. It's pulling this block down the slope. Okay, now we can fill this in. We said that the F is equal to 40 cos 25 degrees. And the FG parallel is equal to 3 times 9.8 sin 30 degrees. We don't know what the tension is, but we do know that the mass of the block is 3 kilograms, and then put 3A. Okay, if we use our calculator and calculate this, we get 36.25 minus minus 14.7 minus T equals 3A. And if we put this in even more, we get 9.25 equals 5A. Hang on a second, sorry. Never mind. We get 21.55 minus T equals 3A. And that is our second equation. Now, because these tensions are the same tension, it's the same force, just acting on the two different blocks, we know that those tensions are the same. We also know that because the blocks are connected, the accelerations are also the same. So what we can do is we can substitute the one sum into the other sum, and then we get that 9.25 equals 5A. Therefore, A equals 1.85 meters per second minus 2. Okay, so how we did that is, from this equation, we said T equals 2A plus 12.3. We changed it around, and then we put this T into the other equation. So we went 21.55 minus, and the T was 2A plus 12.3 equals 3A. We typed it into our calculator all nicely, sorted everything out. And from that, we got 9.25 equals 5A. Because you can see that we substituted that in, we plus the 2A on the other side to get 5A, and then we went 21.55 minus 12.3, and that got us 9. Okay, so the big answer, the final answer, is the acceleration of block P, which is the answer that we wanted. Acceleration of block P is in fact 1.85 meters per second. And in fact, block Q's acceleration is the same because they are connected by a string. So obviously they do have to be the same. Okay. And this question is worth a whole entire 8 marks. So where we're going to get the 8 marks is by saying either F net equals MA or this. 1 mark, another mark here for substituting in, no, 3 marks actually, 1, 2, 3. We've got 4 marks already. Then we get a mark down here, there, one for the whole thing. Nicely, and then we get a mark at the end. So 1, 2, 3, 4, 5, 6, 7, 8 marks in total. Okay, and then the last question for this question is if block P, let me remove some of this. If block P has now passed point B, how will its acceleration compare to that calculated in question 3.2, which was the last question? Choose from greater than, smaller than, or equal to. So remember here, it was a rough surface, and there was friction, and friction acts downwards. So and the force in the next question is staying the same. So we still got the same tension going up. So if we take away this rough surface, we take away the friction, there is less stuff pulling us down and still the same amount of tension pulling us up. So we are going to speed up. So the acceleration is going to be greater than, okay? Greater than. Yeah. And the reason is that there is no friction. Therefore, the F net increases. This means the F net increases is because the force acting up the slope, the net force, which is going to lead to the acceleration, is increasing. Okay. And you can also say that the surface is smooth. And all of those answers will be correct. And you get a mark for saying greater than, and then you get a mark for your reason. So there is no friction you'll get a mark for. You could also get a mark for the F net increases, or you can also get a mark for the surface is smooth. So you can choose between any one of those for what you want to say. Thank you. Okay, this was question 2, and in the next video, I will do question 3.